Tonight, we're going to explore something that sounds far away and cold, but is actually one of the most important places in global politics: Greenland. You've probably seen it on a map and thought very little about it. Leaders and military planners talk about it often when they discuss the Arctic. But here's what most people don't realize. When you truly understand where Greenland sits and what it controls, it changes how you see power in the modern world. This is not just a land of ice and snow. It's a location so strategic that it affects security, trade, and influence across the planet. And by the end of this journey, you're going to understand exactly why the United States cares so much about Greenland, why its role is growing fast, and why this remote island matters more now than ever before. Before we go any further, if you enjoy this kind of deep and simple exploration, a quick like or subscribe really helps the channel grow. It's a small thing for you, but it makes a big difference for me. Now, let's begin. Greenland sits in the far north of the world, its land stretching over 2 million square kilometers, making it the largest island on Earth that is not a continent. From the coastlines to the vast interior ice sheet, the island presents a landscape that is both harsh and striking. The ice covers nearly 80% of Greenland's surface, a thick, unbroken white blanket that rises and falls in subtle curves. From above, the ice seems to merge with the sky, blending into the horizon in a way that hides the land beneath it. The few exposed rock outcrops, fjords, and small coastal settlements provide stark contrast to the immense white of the ice sheet. The sheer scale of Greenland alone makes it significant in any global map, but its importance is heightened by its location in the Arctic, a region that connects the Atlantic and Arctic Oceans and lies close to the northern edges of North America and Europe. This position makes Greenland a natural point of interest for nations concerned with security, shipping, and scientific study. The Arctic location of Greenland places it near major international flight and shipping routes, especially as ice in the northern seas begins to melt in warmer months. The island is not just a landmass, but a gateway to the high north, a place where the shortest paths between North America, Europe, and Asia pass. For centuries, explorers and traders considered Greenland a challenging but strategically valuable position. Today, those historical patterns have become part of modern calculations of defense, research, and commerce. The US, with its northern borders and interest in transatlantic safety, has long recognized Greenland's role as a potential base for observing and monitoring the wider Arctic region. Geography alone has made it a natural point for strategic planning, and the vast ice-covered interior, with its natural barriers, only adds to the sense of isolation and control it offers. Beyond the ice and rock, Greenland is surrounded by water that connects it to both the Atlantic and the Arctic Oceans. The waters around it are cold and often frozen for much of the year, but in summer months, open channels allow ships to move along its coasts. These waters have historically been treacherous, but they are also essential for trade, fishing, and military movement. From a US perspective, access to Greenland's waters offers both an early warning position for monitoring northern seas and a potential launching point for Arctic operations. The island's fjords, deep and winding, provide natural harbors and concealment, useful for ships and infrastructure that require protection from open exposure. Even as the ice dominates the interior, the coasts and the sea lanes around Greenland are living, dynamic areas with significance far beyond what their size might suggest on a map. The vast ice sheet itself, while seemingly lifeless, is of immense importance. It influences global weather patterns, reflects sunlight back into the atmosphere, and contains freshwater reserves that could reshape coastlines if melting accelerates. The ice sheet also makes large parts of Greenland difficult to traverse, creating natural defenses and slowing movement across the land. For any nation considering a presence there, these features are both challenges and advantages. Thick ice can protect installations from ground access, but requires careful planning for construction, transport, and supply. The US has long studied these conditions, understanding that any strategic or scientific investment in Greenland must account for the ice's behavior, the seasonal changes, and the physical demands of the environment. Greenland settlements are few and small, concentrated along the southwestern coast, where the climate is slightly milder and the ocean provides resources. These towns, though small, are hubs of local life and culture, connecting the indigenous Inuit populations with modern infrastructure and external trade. For outside nations, understanding these settlements is crucial for any engagement, whether scientific, military, or political. The presence of communities, even in limited numbers, means that operations cannot ignore local governance, environmental regulations, or the impact of human activity on fragile ecosystems. This human element, though limited, adds complexity to Greenland's strategic value and requires careful consideration in US planning. Historically, Greenland's geography has made it an early point of contact between Europe and the Americas in the north. The ice and sea conditions created natural barriers that slowed movement, but also provided natural observation points. In the 20th century, as aviation and radar technology developed, Greenland's position became even more crucial. The ability to monitor airspace and sea lanes from Greenland offered a forward perspective that could not easily be replicated elsewhere. The island became a key location for early warning systems and air bases, linking the North American continent with European allies and providing a vantage point over the Arctic. Geography alone ensured that Greenland was not just an island of ice, but a critical node in global security networks. The physical terrain of Greenland also includes mountains, glaciers, and valleys that rise between the ice sheet and the coastal areas. These formations create microclimates and influence wind, snow, and temperature patterns across the island. For strategic purposes, understanding the terrain is essential for navigation, construction, and observation. For the United States, maps, satellite images, and historical reconnaissance have been used to plan operations that account for these natural features. Every glacier, every fjord, every ridge can affect visibility, accessibility, and safety. Greenland's geography is not uniform. Its variation in elevation and ice thickness makes planning both complex and necessary. Another aspect of Greenland's geography is the proximity to the North Pole. While the island itself is not at the pole, it is a major stepping stone for any operations or research in extreme northern latitudes. For the US, this has meant that Greenland can serve as a base for both monitoring Arctic conditions and projecting influence northward. The location offers the advantage of being closer to key polar routes than the continental United States, which can reduce response times in scientific, commercial, or defense activities. The combination of proximity, elevation, and ice coverage makes Greenland a uniquely positioned landmass in the Arctic equation. Greenland's strategic significance is reinforced by the patterns of the sun and ice throughout the year. Long periods of daylight in summer and extended darkness in winter create operational challenges, but also opportunities for observation. The reflective ice and snow alter visibility and temperature, impacting everything from radar, readings to human endurance. For any nation, including the US, understanding these cycles is essential for planning sustained operations or research campaigns. the rhythm of light and dark, the shifting ice, and the extreme temperatures all interact with geography to define Greenland's importance in practical, measurable terms. Finally, the combination of size, ice coverage, coastal access, and proximity to other continents makes Greenland a land of immense potential value. It is not simply a remote Arctic island. It is a natural fortress, a monitoring point, and a gateway. For the United States, this geographic and physical profile has informed decades of strategic thought, from early exploration to Cold War planning and modern climate and defense strategies. Greenland's sheer presence on the map forces nations to consider its role carefully, and its environment demands respect, planning, and adaptation. Geography, in this way, becomes the first lens through which Greenland's importance is understood, a base from which all other considerations, scientific, military, and political, stem. The ice in Greenland is not just a frozen surface. It forms one of the largest ice sheets on Earth, holding more fresh water than any other single place outside Antarctica. Its weight presses down on the land, shaping valleys and mountains beneath it. The ice moves slowly, sliding toward the ocean in massive rivers called glaciers. Each year, Greenland loses ice to the sea, a process called melting, and gains ice from snowfall. This balance is delicate, and small changes in temperature can tip it. If the ice sheet shrinks, global sea levels rise. Coastal cities around the world could face flooding, making Greenland's ice a matter not just for scientists, but for millions of people living far away. For the United States, rising sea levels pose threats to major cities, ports, and infrastructure, which makes monitoring the ice a strategic priority. Scientists have long built stations across Greenland to study this vast ice sheet. These stations are small clusters of buildings, often surrounded by tents and equipment, placed in locations that capture different conditions. They measure temperature, snowfall, wind, and ice movement. Some stations are permanent, manned year-round, while others are seasonal, operating only in summer when conditions are less harsh. The work is difficult. Temperatures drop far below freezing, storms blow across the ice, and daylight changes dramatically between seasons. Despite these challenges, scientists record data constantly. They use satellites, radar, and GPS to understand ice thickness and movement. Drones and aircraft fly over glaciers to map their flow. Every measurement adds to a growing picture of how Greenland's ice is changing over time. This scientific information is not only useful for understanding local conditions, it has global consequences. When ice melts, it changes ocean currents, which can affect weather in North America and Europe. Data from Greenland helps predict storms, rainfall patterns, and even droughts far from the Arctic. For the United States, this information is vital. Scientists advise policymakers about potential disasters, and military planners also study the ice. The stability of Greenland's ice can affect access to northern sea routes, the operation of bases, and the timing of Arctic exercises. The ice is a natural barrier, but its retreat could open new paths for ships and aircraft. Understanding its behavior is key for both protection and planning. The glaciers of Greenland are slow, moving sometimes just a few meters each day, yet they carry huge amounts of ice to the sea. When a glacier reaches the ocean, pieces break off, creating icebergs. These floating blocks of ice drift with the currents, creating hazards for shipping. For the US, monitoring glacier movement is crucial to prevent accidents along Arctic shipping routes. As global temperatures rise, glaciers accelerate, sending more ice into the ocean. Researchers can measure these changes, noting how fast ice is leaving Greenland. The data helps governments, companies, and the military anticipate changes to navigation and supply lines. Every shift in ice flow matters, because even a small change can impact large regions. Melting ice also reveals the land beneath. Scientists have discovered valleys, lakes, and mountain ranges hidden under thousands of meters of frozen water. These findings help explain Greenland's history, showing how the land formed and how ice has grown and shrunk over millennia. The land itself can influence how ice melts and moves. Higher regions are colder and accumulate more snow, while lower valleys may experience faster melting. Understanding the landscape helps predict future ice behavior. For planners in the United States, these predictions inform decisions about resource use, military positioning, and climate response strategies. The ice and land together create a complex system, one that must be understood as a whole. Research in Greenland also focuses on temperature records. By drilling into the ice, scientists can retrieve ice cores, long cylinders that contain layers of ice built over thousands of years. Each layer traps air bubbles, dust, and other particles. These cores act as time capsules, showing past temperatures, greenhouse gas levels, and volcanic events. Studying ice cores reveals long-term climate trends, which help scientists understand how fast the Earth is warming. For US policymakers, these records are more than scientific curiosity. They provide evidence for environmental planning, energy decisions, and national security assessments. Knowledge of past climate patterns gives insight into future risks and opportunities. The US military also monitors Greenland's ice. Thule Air Base, at the northern edge of the island, relies on stable conditions for radar, communications, and transport. Ice melt and shifting glaciers can affect runway stability, supply routes, and satellite ground links. Military scientists work with civilian researchers, sharing satellite data and weather observations. This cooperation ensures that both scientific knowledge and operational readiness are maintained. Changes in ice conditions can have immediate implications for security. Even a small acceleration in ice melt may alter how bases operate or how quickly ships can move through nearby waters. Climate change is making Greenland's ice more unpredictable. Summers are warmer than in past decades, causing more meltwater to flow into rivers and fjords. This meltwater lubricates the base of glaciers, allowing them to slide faster toward the sea. Winter snowfall may not be enough to replace the lost ice. The result is a gradual decline in ice mass, visible from satellites and measured on the ground. For the United States, tracking these trends is critical. Faster melting could open Arctic shipping lanes sooner, but it could also increase risks from icebergs, flooding, and unstable terrain. Policy decisions, scientific research, and military planning all depend on accurate and current information from Greenland. Greenland's ice also influences the ocean beyond its shores. Freshwater from melting glaciers enters the North Atlantic, affecting salinity and ocean currents. These currents play a role in global climate systems, including the Gulf Stream, which brings warmth to Europe and the eastern United States. Scientists study Greenland's ice to understand these interactions. Changes in ocean circulation can impact fisheries, energy production, and coastal safety. The US monitors these patterns closely because any disruption to currents could have economic and strategic consequences far from Greenland itself. In addition to the large ice sheet, Greenland has smaller glaciers and ice caps along its coasts. These features respond more quickly to seasonal changes, giving scientists a near real-time view of ice behavior. Observing these smaller systems allows predictions of larger ice sheet trends. The combination of satellites, drones, field stations, and ice cores creates a layered understanding of Greenland's frozen environment. For the United States, this layered knowledge informs decisions about infrastructure, emergency preparedness, and Arctic strategy. Greenland's ice is not just frozen water. It is a living system, changing constantly, influencing oceans, weather, and security. Finally, the scientific work in Greenland strengthens the broader understanding of climate change. The US relies on data from the island to make informed choices about energy, environment, and defense. The ice sheet acts as a mirror, reflecting both sunlight and global trends. By studying it, scientists can see the planet's warming more clearly, while planners can prepare for rising seas, shifting oceans, and new Arctic conditions. Greenland's ice is a natural laboratory, offering lessons that extend far beyond its borders. Its size, movement, and climate impact make it a place of enduring importance to the United States, connecting science directly to policy, security, and the future of the planet. During the Cold War, Greenland became more than just a remote island of ice. Its location made it a critical point between the United States and the Soviet Union. The northern reaches of Greenland allowed for observation and defense in ways that continental locations could not. In the 1950s, the United States established Thule Air Base, a large military facility in the northwest of the island. The base included airstrips, radar stations, and communication towers. It was designed to monitor the skies for any sign of incoming missiles from the Soviet Union. The base was built on frozen ground, with construction teams facing extreme cold, high winds, and shifting ice. Buildings were raised on stilts to prevent melting ice from damaging them. Roads and airstrips had to be maintained constantly, with snow removal and ice monitoring a daily task. Despite these challenges, the base became a critical part of the US early warning network. Thule Air Base was more than a local outpost. It served as one link in a chain of detection systems stretching across the Arctic. Long-range radar could track planes and missiles from far away, giving the United States and its allies time to respond in the event of an attack. Greenland's high latitude made it possible to detect threats coming over the polar region, a path the Soviet Union might use to reach North America. The geography, once a barrier for explorers and scientists, became a tactical advantage. Every hill, fjord, and ice ridge contributed to a larger understanding of how to place sensors and facilities for maximum coverage. Maps were studied in great detail, and aerial reconnaissance ensured that nothing was missed. Greenland itself became a natural shield, holding key positions far from the continental US, yet close enough to be effective. The presence of Thule Air Base influenced both military strategy and politics. For decades, it provided a constant reminder that Greenland was part of global security calculations. The base housed radar, early warning systems, and, for a time, missile detection equipment. This meant that the US could detect nuclear threats, track them, and communicate with command centers in North America and Europe. Greenland's ice and isolation did not diminish its importance. If anything, they amplified it. Harsh conditions ensured that operations required careful planning and preparation. Soldiers and scientists stationed at Thule learned to work together in extreme weather, maintaining both the base's functionality and the flow of information critical to national security. Greenland also played a role in nuclear strategy beyond observation. The Cold War involved constant calculations of risk and positioning. Knowing where to place facilities, radar, and early warning stations could change the outcome of a potential conflict. Thule Air Base was positioned to give maximum warning time if missiles or planes crossed the polar region. The Arctic route, once only a theoretical path for long-range travel, became a real consideration in military planning. Greenland's location allowed for monitoring that could not be replicated elsewhere. The United States invested heavily in infrastructure, equipment, and personnel, understanding that the stakes were high. The lessons of the Cold War, learned on frozen terrain, continue to influence American military thinking today. The construction of Thule Air Base also taught practical lessons about living and working in extreme environments. Buildings had to withstand temperatures far below freezing, with snowdrifts that could bury equipment and supply lines that were cut off in winter storms. Roads, airstrips, and communication lines required constant maintenance. Even fuel storage posed challenges, as pipelines and tanks could freeze or leak. Engineers and military planners gained valuable knowledge about Arctic construction, transportation, and survival. These lessons were recorded, shared, and applied in later military and scientific projects. Greenland's harsh conditions became a natural classroom for building infrastructure that works under extreme circumstances. Greenland's Cold War history also involved cooperation with Denmark, which retained sovereignty over the island. The Danish government negotiated with the United States to allow military operations while maintaining political control. These agreements required careful diplomacy and respect for local laws. They set a precedent for how foreign powers could work in Greenland, balancing strategic necessity with national sovereignty. The US learned to operate within these frameworks, understanding that military and scientific interests must respect political realities. This history informs how American interests continue today, showing that Greenland's importance is both geographic and diplomatic. Thule Air Base was not the only American facility in Greenland during the Cold War. Smaller radar stations and observation posts were placed in strategic locations, creating a network that stretched across the northern parts of the island. Each post collected data on weather, ice conditions, and aerial activity. The stations were designed to operate autonomously, with support from the main base. Soldiers and scientists rotated in and out, maintaining the network and ensuring that information flowed to Central Command. The experience gained in operating these remote sites shaped future approaches to Arctic operations. Knowledge of logistics, survival, and communication became part of the US strategic toolkit. Greenland also served as a testing ground for technologies during the Cold War. Radar systems, communications equipment, and early warning technologies were trialed under real conditions. The ice, wind, and temperature extremes tested the limits of machinery and personnel. Data from Greenland helped engineers refine equipment to function reliably in harsh environments. The successes and failures informed designs for other Arctic installations, including those in Alaska and northern Canada. Greenland's natural conditions provided a continuous, real-world laboratory for military science. Its lessons extended beyond the Cold War, shaping how the US approaches Arctic defense, monitoring, and climate adaptation. Beyond the physical infrastructure, Greenland's strategic role during the Cold War influenced intelligence and policy decisions. The island offered observation points for Soviet activity, early detection of missile launches, and environmental data relevant to long-range planning. Intelligence analysts relied on information from Greenland to predict patterns and prepare responses. This capability made Greenland a linchpin in the broader US approach to deterrence and national security. Policymakers, military strategists, and scientists all recognized that Greenland's location, climate, and ice coverage were not obstacles, but assets that could provide an early advantage in global security matters. Finally, the Cold War history of Greenland informs current American interests. The lessons learned in building, maintaining, and operating Thule Air Base continue to guide military and scientific planning. Greenland's infrastructure, experience with extreme environments, and position in the Arctic remain relevant as new geopolitical challenges emerge. The US considers both the lessons of the past and the changes brought by climate and technology. Greenland's role in history demonstrates that even remote lands can have outsized significance. Geography, combined with infrastructure and strategic planning, has cemented the island's place in American thinking. The ice and rocks of Greenland are not just terrain. They are a record of history, a source of knowledge, and a foundation for ongoing strategic importance. Beneath the thick ice of Greenland lies a wealth that few can see with the naked eye. Minerals, metals, oil, and gas are buried under kilometers of frozen rock and ice. Some of these resources are ordinary, like iron and copper, but others are rare and highly valuable. Rare earth elements, for example, are essential for modern technology. They are used in smartphones, computers, batteries, and military equipment. Without a steady supply, industries and nations face shortages. Greenland has significant deposits of these rare elements, hidden beneath the ice and rock. Accessing them is not simple. Mining in such a cold and remote environment requires advanced technology, careful planning, and constant adaptation to extreme conditions. Yet the potential is enormous, and countries with the ability to extract these resources could gain both economic and strategic advantages. Oil and gas are another important part of Greenland's potential wealth. Offshore and onshore reserves may exist under the ice and along the continental shelves. As global energy demand grows, countries look to secure new sources of fuel. Greenland's oil and gas are difficult to reach, but not impossible. Advances in drilling technology, floating platforms, and cold weather engineering make it increasingly feasible. For the United States, access to these energy resources offers security in supply. Energy independence, stable pricing, and a reliable flow of fuel all become possible if extraction is managed carefully. Greenland, in this sense, represents both opportunity and challenge, combining natural richness with extreme environmental conditions. Mining metals like zinc, lead, gold, and iron has been part of Greenland's history for decades. Small-scale operations have existed, but as global demand rises, interest grows. Companies from around the world have explored Greenland for deposits of strategic metals needed for modern infrastructure and defense. These metals are essential in construction, electronics, and manufacturing. The value of these resources extends beyond raw material. It also connects to global supply chains. Greenland's isolation makes transporting minerals more difficult, but with planning, ports and shipping routes can handle exports. Every container, every shipment of metal requires careful coordination with weather conditions, ice coverage, and logistical support. The US follows these developments closely, aware that access to rare and strategic metals is linked to economic strength and technological capability. Greenland's mining potential has led to interest from multiple nations and companies. Some investors focus on the economic opportunity, seeking profits and access to valuable commodities. Others view resource control as a strategic matter, ensuring that key materials are available for domestic industries and military uses. The US has studied Greenland's potential in detail. Geologists, economists, and policy analysts examine maps, satellite images, and drilling reports. They measure the likelihood of deposits, the difficulty of extraction, and the global value of each mineral. By understanding Greenland's underground wealth, planners can anticipate economic and political trends. The island is not only a physical space, but also a source of leverage in global markets. Accessing Greenland's resources requires infrastructure. Mines need roads, ports, power supply, and housing for workers. Construction must account for ice, snow, and shifting permafrost. Some areas are suitable for permanent facilities. Others can only support seasonal operations. Weather patterns can disrupt work, and shipping routes may be blocked by ice for months at a time. Technology plays a major role, from drilling machines that can handle extreme cold to navigation systems that track icebergs. Every step of mining is measured, planned, and monitored. The United States evaluates these logistics, both for economic planning and for potential military considerations. Greenland's resources are valuable, but accessing them safely and efficiently requires careful strategy. The rare earth elements found in Greenland are especially important. These minerals, such as neodymium, dysprosium, and terbium, are used in magnets, electric motors, wind turbines, and advanced electronics. They are critical for green energy technology and military equipment. Global supply is concentrated in a few countries, which makes Greenland a potential alternative source. For the United States, having access to these minerals reduces dependency on other nations. It provides security for industries and defense. Scientists and engineers study the geology to estimate the amount of extractable material. Economic analysts calculate the costs of extraction, transport, and processing. Policymakers weigh the benefits of development against environmental and local concerns. In Greenland, science, economics, and policy are intertwined. Oil exploration in Greenland has focused on areas where ice is thinner or has retreated. Offshore drilling in the Arctic Ocean presents special challenges. Icebergs, freezing temperatures, and remote locations increase costs and risk. Despite these challenges, interest persists because the potential rewards are large. Successful oil and gas extraction could supply fuel for decades and contribute to global energy markets. The US monitors these developments, considering both economic benefits and strategic security. Greenland's resources can influence trade balances, energy pricing, and regional influence. Knowledge of where oil and gas lie, how they can be extracted, and when is critical for long-term planning. Greenland's potential for mining and energy also affects the local economy. Mining operations can provide jobs, infrastructure, and revenue for Greenland's government. Ports, roads, and power facilities built for resource extraction benefit communities and increase accessibility. At the same time, the environmental and social impact must be managed carefully. Ice melt, pollution, and disruption of ecosystems can have lasting consequences. The United States studies these factors, balancing strategic and economic interests with environmental responsibility. Successful planning considers both opportunity and risk, ensuring that resource development is sustainable and does not create unintended harm. Strategic metals, such as uranium and platinum group elements, are also found beneath Greenland's ice. These materials are essential in modern technology and defense. Uranium, for example, is important for energy generation, while platinum group metals are used in electronics, aerospace, and medical devices. The concentration of these metals in Greenland, combined with its political stability under Danish sovereignty, makes the island a valuable source outside of more volatile regions. US interest focuses on access, security, and the reliability of supply. Strategic metals from Greenland could reduce dependency on foreign nations and strengthen domestic industries. Knowledge of deposits extraction feasibility, and transportation routes informs both economic and military planning. Mining in Greenland is influenced by seasonal conditions. Winter brings extreme cold, storms, and darkness. Summer provides better temperatures, longer daylight, and safer sea access. Companies plan operations around these cycles, transporting equipment and minerals when conditions are favorable. Logistics is critical. Ships must navigate icy waters, ports must remain operational, and air transport is sometimes necessary for remote sites. Greenland's environment demands careful timing and adaptation. For the United States, understanding these conditions is key. Seasonal shifts affect both economic and strategic calculations, influencing when and how resources can be developed or used for supply chain purposes. Greenland's resources are part of a larger global picture. Minerals, oil, and gas from the island connect to international trade, industrial production, and military readiness. For the US, securing access to Greenland's wealth is not only an economic matter, but a strategic one. Dependence on other nations for critical materials can create vulnerabilities. Greenland provides an alternative, potentially reliable source of resources. Analysts study how extraction, transport, and trade from Greenland would integrate with global supply chains. This knowledge informs decisions about investment, research, and national strategy. Science, economics, and policy converge in Greenland, showing how a single island can influence global dynamics. The combination of resource wealth, accessibility, and strategic location makes Greenland a focus for the United States. Minerals, oil, gas, and metals are all part of a complex system that connects geology with economics and security. Science identifies and measures deposits. Technology enables extraction, and policy guides decisions. Greenland's natural riches are not separate from global interests. They are a key part of how nations plan for energy, industry, and defense. The ice that hides the wealth also protects it, creating both challenge and opportunity. Greenland, in this sense, is more than land. It is a potential hub of resources that could shape the economic and strategic future of the United States. Finally, Greenland's economic potential is closely linked to its environment. Melting ice may reveal more resources, while environmental shifts could create new logistical challenges. Coastal waters provide shipping routes, while inland ice and mountains influence where mines can be built. Every discovery, from rare earth elements to oil deposits, carries implications for trade, diplomacy, and security. The United States considers Greenland's economic potential alongside climate, geography, and history. By combining scientific knowledge with careful planning, policymakers can ensure that the island's resources are used wisely. Greenland's wealth is hidden beneath ice and rock, but its impact is visible across global economies, industries, and strategic calculations. Greenland is not an independent country, though it is large and has its own government. Politically, it belongs to the Kingdom of Denmark. Denmark handles foreign affairs and defense, but Greenland has increasing control over its own domestic matters. This arrangement, called autonomy, allows Greenland to govern education, health, environment, and local resources, while still being connected to Denmark for international decisions. The arrangement is unusual because it gives Greenland power to manage much of its own life, while remaining part of a larger state. This dual structure affects how other nations interact with Greenland, including the United States. Any foreign interest in Greenland must navigate both the local government and the Danish authorities. Understanding this political landscape is key for any discussion about Greenland's strategic value. The Greenlandic government, seated in the capital Nuuk, focuses on local needs. It negotiates budgets, manages public services, and regulates mining, fishing, and other industries. Local officials also represent Greenland internationally in some matters, such as scientific collaboration and Arctic councils. This governance allows Greenlanders to make decisions about their land, people, and economy. At the same time, Denmark retains authority over treaties, defense, and foreign policy. For the United States, this means that cooperation or presence in Greenland cannot bypass these political layers. Every project, whether scientific, economic, or military, must consider both levels of authority. The balance of power creates a careful negotiation process where sovereignty, rights, and strategic interest meet. Self-determination is an important concept in Greenland. The people who live there, mostly Inuit, have a long history and a distinct culture. They seek to maintain their language, traditions, and social systems while participating in a modern economy. Greenland has pursued more autonomy over the decades, gaining control of local resources and policy decisions. At the same time, it faces the realities of being part of a kingdom and the presence of outside powers interested in its land and resources. Decisions about development, foreign engagement, and defense require careful consultation between local leaders and Denmark. The United States has learned to respect this balance, understanding that ignoring local voices can create political tension and reduce cooperation. Strategic interest in Greenland has sometimes conflicted with local priorities. For example, during the Cold War, military facilities were placed with approval from Denmark, but local communities experienced disruption and environmental challenges. In more recent decades, Greenland has sought to protect its environment and regulate economic activity. Mining projects, research stations, and tourism all require local approval and oversight. This shows that even when superpowers have technical or strategic advantages, they cannot operate without consent and collaboration. US planners study Greenland's political system carefully, knowing that any action must respect the structures of governance and the will of the people. Diplomatic dynamics among Greenland, Denmark, and the United States are complex. Denmark often represents Greenland internationally, but the island participates in Arctic councils and scientific partnerships independently. The United States interacts with Greenland in scientific projects, climate research, and occasionally defense discussions. But these interactions require coordination with Denmark. Treaties, agreements, and contracts must navigate this three-way relationship. The result is a careful dance where sovereignty, autonomy, and foreign interest coexist. This political structure is part of why Greenland has been approached cautiously in discussions about potential US purchases or expanded military presence. Local governance affects how resources are managed. Greenland's government controls mining permits, fishing rights, and environmental regulations. It decides which companies can operate, under what conditions, and how profits are shared. Denmark may advise or provide oversight in certain areas, but daily control rests with Greenland. For the United States, this means that any economic or strategic interest must respect local rules. Attempting to bypass them could harm relationships and slow development. Knowledge of local political priorities, environmental concerns, and cultural values is as important as knowledge of the land or its resources. Political awareness is part of strategic planning. Greenland's autonomy has grown over time. The 2009 Self-Government Act gave Greenland more control over its natural resources and allowed it to retain revenue from mining and energy projects. It also recognized the Greenlandic people as a distinct population with rights over their land and culture. This legal framework strengthens the island's ability to make independent decisions, even within the Kingdom of Denmark. The United States studies these laws to understand which projects are feasible, what negotiations are needed, and how agreements must be structured. Knowledge of governance ensures that scientific and economic initiatives proceed smoothly and with respect for Greenlandic authority. The balance of self-determination and foreign interest is ongoing. Greenlanders seek to benefit from global partnerships while protecting their culture and environment. They welcome scientific research, technology, and infrastructure development, but only under conditions that respect local law and sustainability. Denmark helps manage foreign relations, ensuring that superpower interest, including from the United States, does not override local priorities. For planners in the US, this balance is a constant factor. Any potential investments, collaborations, or presence in Greenland must navigate political and cultural expectations alongside technical and logistical planning. Diplomatic negotiations are a careful blend of respect and strategy. Meetings between US, Danish, and Greenlandic officials often include discussions on security, science, environment, and economic opportunity. Greenland seeks transparency and involvement in every decision that affects its land or people. Denmark ensures that international agreements align with its own policy and protect the interests of its kingdom. The United States, in turn, must coordinate all actions with both parties. Understanding this network of relationships is essential for any engagement in Greenland. Diplomatic skill is as important as geographic or scientific knowledge. Greenland's political status influences its strategic role. While the island is geographically crucial, its value is mediated by governance. The autonomy of Greenland means that US interests must be presented in ways that align with local and Danish priorities. Large-scale projects, including military or resource development, require negotiation, permits, and oversight. Political stability allows the island to function reliably, while its autonomy ensures that Greenlanders have a voice. This combination makes Greenland both a valuable partner and a politically sensitive location. Strategy cannot ignore the political framework that governs daily life and long-term planning. Local governance and international influence meet in Greenland's scientific programs. Research stations often involve partnerships with the United States, Denmark, and other countries. These collaborations require agreements, shared responsibilities, and respect for Greenlandic law. The local government regulates environmental impact, labor, and resource use. Scientists, engineers, and planners learn to work within this political system, ensuring their activities support local priorities. The result is a model of cooperation, where science advances knowledge, foreign interest gains access, and local autonomy remains protected. Greenland demonstrates that political structure and strategic value are inseparable. Finally, Greenland's autonomy provides a framework for future decisions. The island can manage local matters, control resource development, and participate in international scientific work, all while remaining part of the Kingdom of Denmark. The United States must respect this framework, coordinating with both Greenland and Denmark in any strategic planning. The combination of self-determination, political stability, and geographic significance makes Greenland a complex but valuable partner. Its government ensures that foreign interest aligns with local priorities, creating a model where diplomacy, law, and strategic planning intersect. Greenland's political structure is a lens through which the island's importance to the United States can be fully understood. In 2019, Greenland entered global headlines in an unusual way. President Donald Trump publicly suggested that the United States should consider buying the island. The idea shocked many, both in Greenland and abroad. Greenland is not a private piece of land. It is part of the Kingdom of Denmark, and governed with increasing autonomy. The suggestion of a purchase was more symbolic than practical, but it reflected the administration's focus on strategic and economic interests in the Arctic. The remarks sparked immediate discussion about Greenland's value to the United States, from its resources to its location, and brought international attention to the island's geopolitical significance. For a moment, Greenland became a center of global debate. The motivations behind the suggestion were complex. Strategically, Greenland offers the United States a forward position in the Arctic, close to potential northern sea routes, and near areas of interest for both military and scientific purposes. Access to Greenland allows monitoring of the Arctic and control over air and sea pathways that connect North America, Europe, and Asia. Economically, the island's wealth of minerals, metals, and potential oil and gas reserves was of interest. Politically, the proposal highlighted American interest in ensuring that Greenland did not become dominated by other powers, including Russia or China, who have shown increasing Arctic activity. These combined factors created a backdrop in which a bold, even symbolic proposal like purchasing Greenland made sense from a strategic perspective. Reactions in Greenland were immediate and clear. Local leaders rejected the idea of being bought. Greenlanders, proud of their culture and growing autonomy, emphasized that their land could not be sold. The suggestion was seen as a lack of understanding of Greenland's governance and the rights of its people. Danish officials also rejected the proposal firmly. Denmark highlighted its sovereignty and the legal reality that Greenland is part of the kingdom. International observers viewed the remarks as unusual, noting the symbolic rather than practical nature of the discussion. While some analysts considered it a negotiating tactic, others saw it as a way to signal US seriousness about Arctic engagement. The discussion sparked widespread commentary about Arctic policy, sovereignty, and diplomacy. The proposal also highlighted Greenland's strategic importance. By publicly discussing the idea, the United States signaled to allies and potential rivals that it considered the island a critical asset. Military analysts noted that Greenland's location allows early warning systems, air monitoring, and potential support for northern bases. The US already maintains a presence at Thule Air Base, and any expansion or additional investment could strengthen capabilities. Public attention reinforced the idea that Greenland is not simply remote or isolated. It is central to Arctic strategy, climate monitoring, and global security planning. The announcement, even if largely rhetorical, brought these facts to the forefront of discussion. The Trump administration's interest in Greenland extended beyond public remarks. Policy discussions considered potential investment, development, and collaboration in scientific and infrastructure projects. Analysts examined transportation, mineral access, and Arctic logistics. Decision-makers weighed the costs and benefits of closer engagement, including the political realities of Greenlandic autonomy and Danish sovereignty. Scientific teams, military planners, and economists all contributed to understanding how US involvement could be expanded without infringing on local rights. Greenland's strategic and resource potential made it a focal point for comprehensive assessment, combining geography, climate, and political factors. The discussion also sent signals to other nations. Russia and China, both active in the Arctic, watched US statements carefully. The idea of purchasing Greenland suggested that the United States was willing to assert influence in ways that went beyond standard diplomacy. Allies in Europe noted the proposal, considering the implications for regional cooperation, Arctic policy, and transatlantic relationships. The debate demonstrated how Greenland can act as a lever in global strategy. Even a hypothetical plan of acquisition forced other nations to reassess their positions and priorities in the region. Greenland's location and resources suddenly became central to a wider conversation about Arctic competition and cooperation. Greenlanders themselves emphasized that foreign interests must be balanced with respect for their autonomy. Local leaders welcomed investment, scientific collaboration, and strategic discussion, but insisted on control over decisions affecting their land. The reaction highlighted the importance of diplomacy and consultation. Any foreign proposal, especially one as bold as a purchase, must consider local law, culture, and consent. The United States' statements, therefore, became an exercise in understanding both opportunity and limitation. Greenland's political structure requires engagement that respects autonomy, while exploring strategic and economic potential. Media attention amplified the discussion. International news outlets analyzed the idea, often highlighting the symbolic nature of the proposal and the strategic reasoning behind it. Experts wrote about Greenland's mineral wealth, military significance, and climate importance. Maps of the Arctic circulated widely, showing Greenland's proximity to North America and Europe. The discussion, while centered on a political statement, ultimately provided public education about Greenland's importance. Citizens and policymakers around the world gained a clearer view of why the island matters in global affairs, particularly for the United States. The Trump administration's remarks also influenced policy thinking. By signaling interest, the United States underscored the importance of investing in Arctic capabilities. Military planners considered improvements in Thule Air Base and infrastructure to support operations in the north. Scientists assessed opportunities for expanded research stations and long-term climate monitoring. Economists and strategic planners evaluated the benefits of resource access and trade logistics. Greenland became a point where science, strategy, and policy converged, and the public discussion prompted renewed attention to the Arctic's evolving role in global affairs. Finally, the discussion of Greenland during the Trump administration emphasized the complexity of Arctic geopolitics. It demonstrated that the island is not simply a remote landmass. Its resources, location, and political status create intersecting interests for multiple nations. The public suggestion of a purchase may have been symbolic, but it revealed the underlying strategic priorities of the United States. Greenland's role in climate science, military strategy, and economic planning ensures that it remains central to policy discussions. The interactions among the United States, Denmark, and Greenland show that influence must be balanced with sovereignty, and ambition must be tempered by diplomacy. Even as headlines faded, the conversation reinforced Greenland's importance in global and American strategy, shaping how policymakers think about the Arctic today. The Arctic is no longer a quiet, frozen region. It has become a space of intense interest for many nations. Russia and China have increased their presence in the north, building ports, research stations, and infrastructure. Russia has long considered the Arctic a strategic zone, extending its military reach and developing icebreakers, bases, and early warning systems. Their northern fleet patrols icy waters, testing navigation routes and monitoring the movement of other countries' ships. China, though far from the Arctic, calls itself a near-Arctic nation and invests in research, shipping routes, and resource exploration. Both countries see the Arctic as a place of economic opportunity, scientific discovery, and strategic positioning. For the United States, these developments signal the need to maintain presence, influence, and access in the region. Greenland sits in the center of this Arctic competition. Its location is crucial. Positioned between North America and Europe, with proximity to the North Pole, it offers control over key air and sea routes. These routes may become increasingly important as ice melts and northern passages open for shipping. Russia and China monitor these developments closely. For the US, Greenland provides an advantage. Bases like Thule allow monitoring of airspace, ocean traffic, and environmental changes. Military planners see the island as a pivot, where control or cooperation can affect global influence in the north. The strategic value of Greenland is not only geographic, but also political, giving the US leverage in negotiations and defense planning. Military stakes in the Arctic are growing. The United States monitors Russian activity, maintains radar and early warning systems, and considers potential expansion of facilities. Exercises in ice and snow test personnel and equipment. Cold weather operations, ship navigation, and aircraft mobility are all practiced to ensure readiness. Russia similarly trains in Arctic conditions, testing forces and technology. China's presence focuses on research, ports, and investment in infrastructure that may support future naval or scientific activities. Greenland's geography allows monitoring of these movements. Its location gives the United States both a warning advantage and a base from which to operate. The Arctic is becoming a strategic chessboard, and Greenland is one of its key squares. Trade is also part of the Arctic equation. As ice recedes, new northern routes become viable. Shipping lanes from Europe to Asia through the Arctic reduce travel time significantly. Countries with access to ports and bases in Greenland could control or benefit from these routes. The United States monitors potential traffic and infrastructure developments to ensure safe passage and maintain trade influence. Greenland's ports, though limited, could become hubs for Arctic shipping. Planning involves ice prediction, port construction, and logistics for both civilian and potential military shipping. Access to Greenland ensures the US can participate actively in Arctic trade while maintaining security over strategic passages. Scientific stakes are intertwined with military and economic interests. Arctic research includes climate monitoring, oceanography, and glaciology. Data collected in Greenland informs global models on weather, sea level rise, and environmental changes. US agencies coordinate with Greenlandic and international scientists to maintain observation stations, satellites, and research missions. Knowledge of the Arctic environment affects navigation, construction, and military readiness. Greenland's research stations offer both science and strategy. By studying the ice, weather, and ocean currents, the United States gains foresight into environmental shifts that may affect trade, security, and resource access. Greenland thus becomes both a laboratory and a strategic vantage point. Russia's Arctic strategy emphasizes long-term control. Its military bases extend along northern coastlines, and it maintains a fleet of nuclear-powered icebreakers to navigate icy seas year-round. The United States watches these movements closely. Russia's expansion is not only for economic gain, but also for defense and assertion of sovereignty over northern resources. China's interest complements this, focusing on shipping infrastructure and investment rather than military presence. Together, these developments create a competitive environment where the United States must balance military readiness, scientific research, and diplomatic engagement. Greenland serves as a focal point in this balance, a place where geography meets strategy. The US has increased its attention to Arctic operations. Thule Air Base continues to monitor airspace, while satellites and sensors track ice, ships, and environmental changes. The United States also collaborates with allies in Arctic Council initiatives, scientific programs, and joint exercises. Greenland allows for real-time monitoring of northern air and sea approaches, providing critical intelligence on both potential threats and opportunities. Planning includes long-term infrastructure, transportation logistics, and environmental risk management. Greenland is a hub where military, economic, and scientific interests converge, shaping the Arctic policies of the United States for decades to come. International observers note that Arctic tensions are subtle yet persistent. Nations compete over resources, shipping lanes, and strategic locations while maintaining cooperation through treaties and scientific collaboration. Greenland's location and infrastructure give the United States a unique position. Any Arctic dispute or negotiation may involve the island directly or indirectly. Its airfields, observation capabilities, and proximity to northern routes make it central to planning for both peaceful and security-focused operations. Greenland's role in international geopolitics is rising as melting ice changes the Arctic landscape, creating both opportunity and risk. Economic competition also drives Arctic interest. Minerals, oil, and gas beneath Greenland's ice have global value. Russia and China are investing in technology to reach remote resources, while the United States monitors these projects. Greenland provides a point where US companies and government initiatives can secure access, participate in research, and maintain influence. Trade, energy, and resources are all interconnected. Greenland becomes a hub where these factors meet, making the island an important pivot in Arctic strategy. Its location allows oversight of key routes and resources, linking economic opportunity with security planning. Greenland's role as a pivot extends to diplomacy. The United States must coordinate with Denmark, Greenland's local government, and other Arctic nations. Treaties, agreements, and Arctic Council participation require careful negotiation. Strategic, economic, and scientific initiatives all require approval, cooperation, and oversight. Greenland is a test case for balancing national interest with international law and local autonomy. The island shows that in the Arctic, influence is not only about proximity, but also about relationship management. Engagement with Greenland demonstrates how strategy, science, and policy intersect in this sensitive and changing environment. Finally, Greenland's significance in Arctic geopolitics is growing. Its location, combined with resources, research capabilities, and infrastructure, makes it a central point for international competition and cooperation. The United States sees Greenland as both a shield and a platform. Its presence ensures monitoring, scientific study, and strategic readiness. Russia and China's activities highlight the importance of maintaining influence, access, and partnerships. Greenland is no longer remote. It is a pivot where military, trade, and science converge. Control and cooperation here influence broader Arctic strategy, global commerce, and national security, making the island an indispensable element in US and international planning. Greenland's ice is melting faster than ever before. Rising global temperatures have a direct impact on the ice sheet, glaciers, and permafrost. Rivers that were once frozen all year begin to flow in summer months. Ice shelves retreat, and calving events send massive chunks of ice into the ocean. The melting affects local communities as traditional hunting and fishing areas change. Inuit families have relied on ice routes for generations, moving across frozen lakes and fjords to gather food and travel safely. Now, thawing ice makes travel unpredictable and sometimes dangerous. Boats and vehicles must replace sleds and snowmobiles. Local knowledge remains important, but the environment is changing faster than people can adapt. Homes and infrastructure near coasts face erosion and flooding, forcing some families to relocate or reinforce buildings. Communities are learning to cope, but the challenges are constant. Indigenous populations are deeply connected to the land. Culture, language, and traditions are tied to hunting, fishing, and seasonal cycles. Ice provides not only access, but also a sense of stability and identity. With the changing environment, younger generations are experiencing a new reality. They balance modern education and technology with traditional skills. Knowledge of animal behavior, ice thickness, and weather remains crucial for survival. Elders pass down guidance, teaching how to read the land, the snow, and the wind. When ice melts or shifts unexpectedly, it disrupts centuries of accumulated understanding. The changing landscape affects diet, transport, and cultural practices. Indigenous communities must adapt while preserving their identity, a delicate balance in a rapidly warming world. Land rights are an important part of Greenlandic society. The Inuit have historical claims to hunting grounds, fishing waters, and areas used for settlement. Greenlandic law recognizes these rights and requires consultation when new projects are planned. Mining, infrastructure, or foreign investment must consider local ownership and use of the land. Economic interest often collides with traditional rights. Companies or governments aiming to extract resources must negotiate agreements, offer compensation, and ensure respect for culture. The United States, when planning scientific, economic, or strategic projects, studies these frameworks to avoid conflict. Cooperation with local authorities and communities is essential for any work in Greenland. Respecting land rights maintains both legality and trust, ensuring that foreign involvement benefits rather than harms the people who live there. Economic development in Greenland faces environmental constraints. Resource extraction, ports, and energy projects can generate revenue and jobs. However, they risk damaging fragile ecosystems. Oil spills, pollution, and habitat disruption threaten wildlife and human health. Even scientific research can have impacts if conducted without careful planning. Local communities, scientists, and policymakers discuss how to balance growth with protection. Environmental monitoring, strict regulations, and sustainable practices are critical. The United States, when engaging in Greenland, must consider these tensions. Policies cannot focus solely on economic or strategic gain. They must also ensure that environmental integrity is maintained. Greenland's environment is not limitless. Mismanagement can have long-lasting consequences for ice, wildlife, and people. Climate change has a direct impact on global concerns. Greenland's ice melt contributes to rising sea levels worldwide. Coastal cities far from the Arctic face increased flooding, storms, and erosion. The rate of melt affects ocean currents, weather patterns, and climate stability. US policy links Greenland's environmental changes to national and global planning. Research stations track ice thickness, temperature, and snow accumulation. Satellites monitor ice sheet movement and melting. Data gathered in Greenland informs models used by scientists and policymakers in the United States and around the world. Understanding the pace and scale of ice loss helps prepare for rising seas, extreme weather, and economic consequences. Greenland is both a warning and a source of vital knowledge. Hunting and fishing practices are also affected by changing ice. Polar bears, seals, fish, and other animals adjust their patterns as the environment warms. Inuit hunters adapt by tracking animals differently, changing hunting routes, and relying on boats more than sleds. Seasonal shifts alter the availability of traditional food, which affects nutrition and cultural practices. When ice melts earlier or forms later, access to hunting grounds becomes limited. Communities must plan carefully to ensure sufficient food for families. Knowledge of wildlife patterns remains critical, but it must be updated constantly. Climate change challenges the traditional timing and rhythm of life that Greenlandic culture has relied on for centuries. Environmental concerns intersect with foreign interest. Mining and oil exploration can disrupt the ice, pollute water, and endanger wildlife. Scientific stations and military facilities also leave footprints on the land. Greenlandic leaders, supported by Denmark, set rules to protect ecosystems while allowing responsible development. The United States must follow these rules when engaging in research, infrastructure, or strategic projects. Environmental impact assessments guide decision-making. Cooperation with local scientists ensures that work is sustainable. Protecting the fragile Arctic environment is part of maintaining long-term strategic and economic interest. Ignoring environmental risks can have both ethical and practical consequences, affecting communities and global climate alike. Greenland's people are deeply involved in environmental decision-making. Local governments consult communities before approving projects. Traditional knowledge, accumulated over generations, complements scientific data. Inuit elders can predict ice behavior, seasonal changes, and wildlife movement. Their guidance helps scientists and planners avoid dangerous areas, select suitable locations for infrastructure, and anticipate environmental consequences. Policies that incorporate both local knowledge and modern science are more effective. The United States, in its Arctic engagement, benefits from listening to local voices. Indigenous participation ensures projects are culturally appropriate, environmentally responsible, and socially acceptable. Greenland demonstrates that environmental stewardship requires collaboration between residents, governments, and international partners. Climate change also creates urgency for research and observation. Rising temperatures, ice retreat, and changes in sea level require constant monitoring. Greenland hosts stations that measure ice thickness, snow accumulation, and temperature trends. Data is transmitted to international research centers and informs climate models. These models guide US policy on energy, security, and environmental planning. Scientific monitoring in Greenland provides early warning of changes that could affect shipping, infrastructure, and coastal safety worldwide. The ice is not only a local resource, but also a global signal. How it shifts and melts has consequences far beyond Greenland's borders, making observation and care a strategic priority. Finally, the environmental and indigenous implications of Greenland's changing climate are central to understanding its importance. Melting ice affects the people who live there, the wildlife they depend on, and global systems of weather and ocean currents. Indigenous knowledge guides adaptation and sustainable practices, ensuring that cultural traditions continue even as the environment transforms. Economic interest, including resource extraction and infrastructure development, must be balanced with environmental protection and local consent. US policy in Greenland cannot ignore these realities. The island demonstrates that geography, climate, and human presence are intertwined. Respect for the environment and indigenous rights is not optional. It is fundamental to responsible engagement in the Arctic. Greenland is a place where science, culture, and policy meet, and its future depends on careful consideration of all three. Greenland's ice and rugged coast hide a network of infrastructure that is vital to Arctic strategy. Thule Air Base, at the northern edge of the island, is the most well-known installation. It operates year-round, monitoring airspace and missile activity, and supporting scientific missions. Radar systems provide early warning detection for the United States and its allies. The base is surrounded by snow, ice, and barren rock, yet it is a hub of activity. Runways are maintained for aircraft capable of handling extreme cold. Storage facilities hold fuel, equipment, and supplies for long-term operations. Roads connect sections of the base, though they are limited and often impacted by snowstorms. Every detail is adapted to the Arctic environment, where temperatures can drop far below freezing and winds whip across frozen plains. Ports are fewer and less developed, but remain essential. Harbors allow supply ships to bring food, fuel, and equipment. Ice conditions limit access during winter, requiring icebreaker support. The United States and Denmark coordinate to maintain navigable routes for military and research purposes. Cargo operations require precise timing to avoid dangerous ice. Floating docks, reinforced piers, and temporary staging areas are common. They must withstand ice pressure, storms, and seasonal changes. Ports in Greenland are not merely logistical points. They are strategic access points that connect the island to North America, Europe, and the Arctic Ocean. Each shipment reinforces the ability to operate far from home. Airfields complement ports and bases. Thule's runway allows large military aircraft to land, deliver supplies, or conduct training. Smaller airstrips in other parts of Greenland support local communities, emergency transport, and scientific research. During the summer months, aircraft can access more remote areas, assisting exploration, surveying, and environmental monitoring. In winter, flights become riskier, but remain crucial for continuity of operations. Every airfield must account for snow accumulation, frozen ground, and wind conditions. Greenland's airfields, though sparse, provide the United States with mobility and reach in a region where road networks are minimal and the sea is often frozen. Future potential for U.S. military expansion exists. New radar stations, communications hubs, or refueling points could be developed to enhance Arctic coverage. Satellite-linked systems would allow monitoring of ships, aircraft, and ice conditions across the Northern Hemisphere. Expansion is complicated by weather, geography, and political considerations, but it is feasible. Existing infrastructure provides a foundation for growth. Scientists and engineers study how to build or upgrade facilities with minimal environmental impact. U.S. planners consider how new infrastructure can support both military readiness and scientific observation, creating dual-use benefits. Greenland's position allows forward deployment, rapid response, and strategic surveillance. Scientific expansion also intersects with military planning. Research stations studying climate, ice, and the atmosphere provide data crucial for navigation, logistics, and operational planning. Satellites, sensors, and ground-based monitoring stations all contribute to situational awareness. Observing ice thickness, currents, and weather patterns informs shipping routes, aircraft safety, and base operations. The United States can use these observations to anticipate changes that may affect both civilian and military activities. Greenland's scientific capacity becomes part of strategic planning, providing a knowledge advantage that enhances Arctic readiness and safety. Surveillance in Greenland is critical for broader security. Thule and other monitoring points track airspace across the Arctic, including potential activity from Russia and other nations. Early warning systems detect missile launches and provide alerts to US and Allied command centers. Radar coverage extends far beyond Greenland, making the island a hub for hemispheric defense. The Arctic environment poses challenges: extreme cold, auroras affecting signals, and harsh terrain. Engineers and military planners adapt technology to these conditions. Surveillance infrastructure allows the United States to maintain awareness of movements in the north, contributing to global security and rapid response capabilities. Missile defense is another key consideration. Greenland's northern location allows monitoring of potential threats from distant regions, offering time to prepare and respond. Sensors, radar arrays, and communication links integrate with global defense networks. Early warning capability enhances U.S. readiness, giving both strategic and tactical advantages. Greenland serves as a forward point where technology and geography combine to extend coverage. The ability to detect, track, and respond to missile activity contributes to deterrence, regional stability, and protection of North American and allied interests. Logistics in Greenland are complex. Supplying bases, research stations, and airfields requires planning for ice, snow, and remoteness. Resupply often involves a combination of ships, aircraft, and overland transport. Seasonal changes dictate timing, while extreme weather demands contingency plans. Fuel, food, and equipment must be stockpiled in advance. Storage. Facilities must withstand freezing temperatures, high winds, and shifting ice. Every logistical decision is calculated to ensure continuity of operations in the Arctic. Greenland is both a challenge and an advantage. Its remoteness complicates planning, but also provides security and isolation for sensitive installations. The strategic advantage of Greenland is evident in times of global conflict or crisis. Its location allows monitoring of northern approaches to North America and Europe. Aircraft, ships, and satellites can operate from or through Greenland to respond quickly to threats. Forward presence in the Arctic extends the reach of U.S. forces and provides an observational platform in a region where geography favors early detection. In a crisis, infrastructure in Greenland supports rapid deployment, communication, and coordination with allies. The combination of existing bases, potential expansion, and natural geography gives the United States a unique advantage in the polar north. Finally, Greenland's military and infrastructure planning balances opportunity with limitation. Harsh weather, ice, and remoteness restrict activity, but they also provide security. The island offers observation, early warning, mobility, and logistics in a region critical for global strategy. Expansion must consider environment, indigenous rights, and political consent, yet the benefits are significant. Greenland is not simply a frozen land. It is a strategic hub, linking science, defense, and global planning. Its facilities, ports, and airfields allow the United States to maintain readiness, monitor international activity, and respond effectively to changes in the Arctic. The island's geography and infrastructure make it a cornerstone of U.S. strategic planning in the polar region. Greenland's future holds a unique place in global politics. Its location, size, and resources make it increasingly important for the United States and other nations. In the 21st century, the Arctic is no longer distant and frozen. It is changing rapidly. Melting ice opens new sea routes and exposes resources previously locked under snow and ice. Greenland sits at the center of these changes. Its land, ice, and waters influence climate, trade, and security far beyond the Arctic. Decisions made about Greenland today will echo for decades. For the United States, it is both a partner and a point of strategic interest, shaping policy on science, military presence, and international relations. Climate change continues to redefine Greenland's significance. Ice melt raises global sea levels, affecting coastal cities and ecosystems around the world. Changes in ice coverage influence shipping lanes, making Arctic passages more navigable for longer periods each year. For military planners, These developments create opportunities and challenges. Bases like Thule may need upgrades or expansion to support new operations. Scientists can study the melting ice to understand global weather patterns and predict risks. Greenland becomes a place where science, security, and climate awareness converge, giving the United States a perspective on both local and global changes. Knowledge from Greenland informs energy policy, environmental planning, and long-term strategic decisions. Resources under Greenland's ice remain central to its global importance. Rare earth minerals, oil, and metals are valuable for technology, industry, and energy. The United States studies the potential of accessing these resources responsibly. Greenlandic law and local governance guide how foreign countries can operate. Balancing resource development with environmental protection and cultural respect is critical. Access to resources contributes to economic security and reduces reliance on external suppliers. Greenland's mineral wealth, combined with its location, makes it a key factor in planning for global supply chains and strategic independence. The island is more than a landmass. It is a potential hub for both industry and security. Strategic positioning complements climate and resources. Greenland's proximity to North America, Europe, and the Arctic Ocean provides an unmatched observation point. Airfields and ports support both scientific and military operations. Satellites, radar, and monitoring stations track activity across the polar region. Any nation with presence in Greenland can influence Arctic shipping, surveillance, and research. For the United States, this position ensures awareness, readiness, and flexibility in the north. Greenland acts as a natural outpost where climate study, logistics, and security intersect. Its geography gives tangible advantages that cannot be replicated elsewhere, making it central to Arctic policy planning. U.S. interests in Greenland will evolve depending on political leadership. Different administrations may emphasize science, climate monitoring, military preparedness, or economic opportunity. Investment in infrastructure, technology, and personnel will vary. Policies will adjust to reflect international dynamics, including Russia and China's Arctic activities. Cooperation with Denmark and Greenland will continue to be essential. Regardless of political changes, Greenland's geographic and strategic value remains constant. It serves as a hub where policy, science, and security converge, requiring thoughtful planning and collaboration. Flexibility and long-term vision are key to maintaining influence and partnerships in the Arctic. International cooperation will continue to shape Greenland's role. Treaties, research partnerships, and Arctic councils provide frameworks for engagement. Greenland participates in these efforts through local governance and collaboration with Denmark. The United States works alongside other nations to study climate, ensure safe navigation, and monitor regional activity. Greenland's presence facilitates scientific exchange, environmental protection, and strategic coordination. Its position allows observation of neighboring nations' activity while providing opportunities to lead research and policy initiatives. Greenland is a bridge between national interests and global responsibility, showing how one location can influence broader cooperation and competition. Future military and infrastructure planning in Greenland will integrate lessons learned from past decades. Existing bases, airfields, and ports provide a foundation for expansion. Scientific stations inform logistics and monitoring. Climate change and resource exploration create new demands for infrastructure. Planners must balance environmental protection with operational readiness. Greenland offers a controlled forward position in the Arctic, enhancing both observation and response capabilities. Its facilities support hemispheric defense, early warning systems, and scientific monitoring. while remaining sensitive to local needs and international agreements. Planning must be precise, adaptive, and sustainable to preserve both strategic and environmental value. Greenland also serves as a lens to understand Arctic global policy. Its ice, land, and people reflect the intersection of climate, sovereignty, resources, and international interest. By studying Greenland, policymakers can learn how nations balance local autonomy with global strategy. The island illustrates the challenges of operating in extreme environments, respecting Indigenous rights, and coordinating multinational efforts. Greenland provides lessons in diplomacy, science, and long-term planning. It shows that strategic decisions in remote areas require knowledge, patience, and respect for both natural and human systems. The Arctic cannot be understood fully without considering Greenland's central role. Environmental stewardship will remain a priority. Greenland's fragile ecosystems, cultural heritage, and ice sheet require careful management. Scientific monitoring will track changes in temperature, ice thickness, and ocean currents. Research informs international policy, disaster planning, and climate mitigation strategies. Greenland is not just a site of observation. It is a laboratory for understanding global environmental change. The United States and other nations must integrate this knowledge into policy and planning. Greenland's future is intertwined with global climate, making its protection essential for both science and strategy. In the decades to come, Greenland's significance will likely increase. Climate, resources, and strategic position make it central to Arctic and global policy. The United States will continue to consider Greenland in scientific, military, and economic planning. Cooperation with Denmark and Greenlandic authorities ensures that actions are lawful, respectful, and effective. The island remains a pivot where geography, resources, science, and strategy intersect. Observing, studying, and operating in Greenland provides insights that extend far beyond the Arctic, shaping decisions on climate, security, and international relations. Its importance is enduring and multifaceted. Ultimately, Greenland is a place where many forces meet. Climate change, resource potential, military positioning, and indigenous culture all converge. The United States sees Greenland as an essential partner and strategic point. Its location allows monitoring, research, and operational reach in the Arctic. Its governance and people ensure that foreign interest is balanced with autonomy and respect. Greenland demonstrates that remote regions can have global significance. Policy, science, and strategy intersect here in ways that affect the entire Northern Hemisphere. The island remains a cornerstone for understanding and acting in the Arctic now and in the future. Greenland's role in the 21st century shows that geography and governance shape global strategy. Its ice informs science, its land supports infrastructure, and its location enables security operations. Resources beneath the ice offer economic and strategic leverage. Local governance ensures that foreign engagement is responsible and cooperative. The United States, along with other nations, must work carefully and thoughtfully to balance opportunity, risk, and ethical responsibility. Greenland illustrates how a single place can influence climate understanding, international relations, and global security. Its importance will only grow as the Arctic continues to change. In reflection, Greenland embodies both challenge and opportunity. Harsh conditions, environmental fragility, and remoteness make operations difficult. At the same time, its location, resources, and scientific value make it indispensable. The United States recognizes this complexity in its planning and partnerships. Greenland will remain central to Arctic policy, global strategy, and climate research. It is a place where practical challenges meet strategic opportunity, where science meets security, and where local governance meets international interest. Understanding Greenland is key to understanding the modern Arctic and the future of global geopolitics.